Morning we have seen how to draw BODE plot. Now let us draw BODE plot for given sum. Draw the BODE plot of the open loop transfer function g of s equal to 200 multiplied by s plus 10 upon s multiplied by s plus 5 multiplied by s plus 20. The first step is we have to convert the given transfer function into time constant form. It is not in time constant form. This is not in time constant form. It is not in time constant form. That's why we have to convert this into time constant form first. So to convert this into time constant form, g of s equal to, we have to take 5 and 20 outside, that is 100 s multiplied by 1 by 5 s plus 1, 1 by 20 s plus 1. Numerator 200 multiplied by 10, 1 by 10 s plus 1. So now it is in time constant form. What is the gain? Gain is 20. 20 multiplied by s by 10 plus 1 upon s multiplied by s by 5 plus 1 s by 20 plus 1. 3 first order factors are there, 2 in the denominator and 1 in the numerator. First we have to prepare, we have to find frequency transfer function. 20 j omega plus 1 upon s multiplied by 0.2 j omega plus 1, 1 by 20, 0.05 s plus 1. Therefore, the table now we have to prepare. Number of factors. Then what is the factor we have to write? Corner frequency we have to write. Then net slope contributed by this factor in dB per decade. Net slope. Then coordinate. The first one is 20 upon j omega. First factor is 20 upon j omega. No corner frequency. No corner frequency. The slope is, it is in the denominator, that's why minus 20 dB per decade. Net slope also minus 20 dB per decade. Coordinator, we have to find the corner frequencies are, 5, 10 and 20. 5, 10 and 20 are the corner frequencies. Lowest is 5. Therefore, we have to start with 0.1. 0.1 comma y coordinate we do not know. We will find later. Then second factor is lowest corner frequency we have to write first. Lowest corner frequency that we have to write first. What is the lowest? 5. 5 means we have to write 1 by j omega plus 5. Or you can write 0.2 j omega plus 1. So let us write in time constant form. So the corner frequency is 5 minus 20, therefore minus 40, and the coordinate is 5 comma. The next one is 0.1 j omega plus 1 plus 0.1 j omega plus 1. Corner frequency is 10 plus 20. That's why minus 20, 10 comma. The fourth factor is 1 upon 0.05 j 0.05 omega plus 1. The corner frequency is 20. Then net slope, the slope contributed is minus 20. Therefore, net slope is minus 40. And the coordinates 10 comma and 100 comma. Final, that's why 2 coordinates we have to find. That's all. Now we have to find the coordinates one by one. Here, if you find the dB scale, this 20 by omega, that is 20 log 20 by omega. That is equal to omega equal to 0.1, because the scale starts with 0.1, because lowest frequency is 5 only. That's why we will start with 20 log 0.1, sorry, 20 divided by 0.1 equal to how much? (46 dB). 46 dB. Therefore, the coordinate is 0.1 comma 46. The next here we have to find for that, this is omega 1, omega 2, y1, y2 we have to find. Y2 equal to, what is the slope? We have to consider the previous slope, that is minus 20 log of omega 2 by omega 1, 5 divided by 0.1 plus y1, that is 46, equal to how much? 12 dB. So here you will get 12. Again, y2 equal to, this is omega 1, this is y1. We have to find y2. That is minus, that is previous slope is minus 40 log omega 2 is 10 by 5 plus y1 is 12. That is equal to minus 0.04. Here 0.04 but minus. Y2 equal to, the previous slope we have to put minus 20 log omega 2 is 20 divided by 10 plus minus 0.04. That is equal to how much? Minus 6. Minus 6. Now for 200, it is simple. For 200, what is the slope? Minus 40. After that corner frequency, it is minus 40. We have to add, here it is minus 6, minus 6, minus 40, minus 46. That's all. Now we have to draw the magnitude plot. We have to draw the magnitude plot. 0.1, 1, 10, 100, log omega. What are the coordinates? 0.1, 46 dB scale. Then 0.1, 46, 512. 5 will be around here. For 512, then 10 minus 0.04. 10 minus 0.04. Minus 0.04. Then 20 minus 6. 20 is around here. Minus 6. And 40, 100, 200. 200 will be here. 200 is about minus 46. So we have to join all the lines to get the plot. This is magnitude plot. Now we have to draw the phase plot. To draw phase plot, we have to consider this. So angle of G of j omega equal to, there is no angle for 20. Angle for 20 is 0 because only real part. Here 0.1 omega by 1. Tan inverse of positive. Tan inverse of 0.1 omega minus tan inverse of 0.2 omega. 0.2 omega minus 0.05 omega. Tan inverse of 0.05 omega minus 90 degree. Because for this j omega, you will get 90 degree. So here, now we have to prepare the table for phase omega, angle of G of j omega. Both we have to write. We have to find for 0.1. We have to find 1, 5, then 10. We have to find where it crosses. Generally, we have to see where it crosses. It actually crosses at this is 0.1, 1, 10. Actually, it is crossing at 10. If you know where it crosses 0 dB, that point also you have to include. That point also you have to include. I will let you know later why. Zero crossing. That frequency also you have to include. That frequency is called omega GC. That frequency is called omega GC. Here it is 10. That's why I'm not including that omega GC. Then you have to include 10. Then what is there? 20 is there. Then 200 is there. That's all. For all this, you have to find the angle. For all this, you have to find the angle. If you put infinity, what you will get? You can include infinity also. Final angle. If you put omega equal to infinity, this becomes 90. This becomes 90. This also becomes 90. These two are negative. Minus 90, minus 90, plus 90. So 3 minus 90, 1 plus 90, therefore 180. As omega tends to infinity, the final angle of G of j omega equal to minus 180 degree. So that also you can include minus 180 degree. If omega equal to 0, what you will get? Angle. Tan inverse of 0 is 0. When omega tends to 0, angle of G of j omega equal to minus 90 degree. That's why it will start at minus 90, end at minus 180. So all these values must be between minus 90 and minus 180. If you get any other value, maybe mistake. That's why you should be careful. So for that, it is better to find for omega equal to 0 and omega equal to infinity, so that you will know the range of angle. So the range of angle is minus 90 to minus 180. If you get any other angle, it's wrong. Find the angle. For all corner frequencies, we got the angle. Now we can plot the phase plot. This is the phase plot. This is the actual plot drawn on semi-log sheet. Now we have to find the gain margin and phase margin. Here, to find the gain margin and phase margin, to find the gain margin, where it crosses 180, we have to see. Where it crosses 180 at infinity only. Where it crosses, because its maximum value, maximum angle is 180. That's why it crosses at 180 only. Therefore, here at infinity, it crosses minus 180. Where it crosses 180, we have to check. At that point, what is the magnitude? This also went to infinity, because the magnitude also went to infinity. The magnitude also went to minus infinity. Therefore, gain margin is infinity. This you may not be able to understand now. We'll see later. I'll make you understand this gain margin infinity later. Phase margin. To find phase margin, where it crosses 0 dB, we have to check. 0 dB, here it crosses. There you have to draw a vertical line. There we have to see the angle. Angle is 1 division above 150, therefore minus 140. Minus 140. Therefore, phase margin equal to 180 minus 140, 40 degree. Therefore, phase margin is 40 degree and the gain margin is infinity. Gain margin infinity means you can increase k any amount of value. It will not become unstable. In other words, the root locus will not cross the j omega axis if you increase the gain. But there is a threat in the phase. If you introduce a phase shift in the feedback loop about 40 degree, minus 40 degree, then this minus 40 becomes, this minus 140 becomes 180, minus 180. If you introduce a phase shift, it becomes 180. That's why it becomes in the verge of instability. So in two ways, you can bring the system to instability. One is by increasing gain, that you can understand from gain margin. Another reason is by introducing phase shift. If you introduce a phase shift of 40 degree, additional phase shift of 40, already it has a phase shift of minus 140. If you introduce additional phase shift of 40 degree, it becomes in the verge of instability. Even though it doesn't become unstable for if you increase any amount of k. But if you increase phase shift, it becomes unstable. That is called gain margin and phase margin. Only I have to explain what is gain margin. That is the next slide. But the want of time today, we cannot see. Tomorrow we'll see what is gain margin and phase margin.